The function of g of x is defined by g of x is equal to ax cubed plus bx squared plus cx and then plus d. Has the following properties. Use the following information to draw a neat sketch of the graph without actually finding a, b, c, and d. So what have you been doing? We've been able to find the value of a, b, c if we are given the x-intercept. So here we are going to be using the following properties. Here it wants you to understand the properties of a cubic function. And then we're going to be using the following properties that they gave us here so that we can draw a neat sketch. Now, how do I approach this one here? For example, they are saying which g of 0, x is 0. When x is 0, what is my y? Yeah, so I will tell them which when x is 0, my y is going to be equal to 32. What will we call this? An x-intercept or a y-intercept? It's our y-intercept. Okay, sharp. Let's check. What else did they give us? They gave us g of 4. What is x? When x is 4, what is our y? It is 0. What do we call this? An x-intercept or a y-intercept? So this one is our x-intercept. Okay, let's go to this one. G of minus 2. So we have minus 2 is to what? Is to 0. Another x-intercept. Okay, so we have our x-intercept, and then we also have our y-intercept. Now they went on to say, okay, but yes. They went on to say we have g prime of 0. G prime of 0 is
0.
G prime of 0 is what is
0.
So in other words, when x is equal to 0, what is our y?
0.
Our gradient. Our gradient is 0. It means we are at the turning point. That's what they're trying to tell you here. They're saying g prime of 0 is equal to what? What does this mean? It means when x is equal to 0, our gradient is going to be equal to what? But do we know what is our y? We don't know what is our y as yet. Let's try this one. G prime of 4. G prime of 4. Now, when x is equal to 4, what is our gradient?
0.
Our gradient is 0. So let's call this 1 point prime. I'm also going to call this 1 point prime. We still find them. So what does our graph turn? Our graph is going to turn at what and what? When x is equal to 0 and x is equal to what? 4. Okay, so we know what our graph is going to turn at x is 0 and x is equal to 4. Now we can go and try to plot these things based on the information that we have. Let's start with the intercepts. Our intercepts we have, let's say which we have 1, 2,
3, 4, 5.
we have 1, 2,
3, 4. You can see
1, 2, 3.
4, 5.
So we have 1, 2, 3, 4, 5. We have 1, 2, 3, 4. Okay, we have minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. Okay, give me the x-intercept based on what we said here. What did you get as our x-intercept? We have 4 and 0. Ne? Okay, we have 4 and 0. We are going to write it 4 and 0. Here it is. 4 is to 0. Sharp. This is x-intercept. What is the other x-intercept that you have? Minus 2, it goes with 0. Minus 2 goes with 0. Okay. So we have minus 2, which goes with 0. What is the y-intercept that we got? So this one, when we have 0 is to 32. So we can use 4, 10, 20, 30, 40. So 32 is somewhere here. Okay, sharp. What else do we have? We have the turning point, and the x values of the turning point. So we have 10, 20, 30, and then here we have 32. Okay, the first turning point that we have, I'm going to use a different color for the turning point. Let's use red, for example. Let's use that.
Purple.
Green. Okay. So turning point number one, what do you have as your turning point number one? We have 0 is to 0. We have 0 as the turning point. X value is 0. Ne? And then our M is also going to be what? To be 0. Okay. What is the other turning point that we have? We have what? We have 4 is to what? Is to 0. Now our graph is going to be turning here. It can either turn, look upwards, or it can either turn and look what? And look downwards. That's what we know. Okay. And then at the same time, we wanted to know which when X is 0, what is our Y? We know when X is 0, what is our Y? We know that. They told us from the beginning here. They said, when X is 0, when X is 0, what our Y is equal to what? To 32. So where is your graph going to turn? Our graph is going to turn at the x-intercept. At the y-intercept, yes. So how is our graph going to look like then? Our graph is going to look like this then. And this is how our graph is going to look like. Now let's go and check which it does just satisfy all the conditions that they are talking about here. Look at this. They said something like this. They said they said, look at this. They said when g prime of x is greater than 0, x is going to be an element between x should be less than 0 and x should be greater than. So when the gradient is positive, when our graph is increasing, when our graph is when our graph is increasing, it's going to increase when x is less than 0. Check here. Is your graph increasing here? Look at this part here. Is your graph increasing here? Starting from here to here, is your graph increasing? No. It is getting bigger. And then it satisfies the condition. And then they also said which our graph is going to decrease when f prime of x is between 1 is to 4. That's what they said here. G prime of x is less than 0. It means that the gradient is negative. The gradient is going to be negative between 0 and what? And 4. Let's go and check it. Does it satisfy that condition here? Come and check. Between 0 and 4, what is your gradient? Is it negative here? Yes. Negative. So this is how your graph is going to look like. Yes. Guys, here's the mistake that learners make. They want to say G prime of x is equal to y. It's not. It is the turning point. When they say G prime of something, if I say to you G prime, I say G prime of 4 is equal to 0. I'm saying the gradient at the turning point when x is 4 is equal to 0, which we know very is true. The gradient at the turning point is going to be equal to what? To 0. So after that, when you need to go and find which when x is 4, what is going to be y? They need to tell you on the statement here. When x is 4, what is going to be y? Now, yes, my leader, I'm listening. I need to go back to the equation. Yes. That 0 is to 0. 0 is to 0. It's the kind of what is this? Is the point prime. Is the point when x is equal to 0, the gradient is equal to what? To 0. It's not x is to y. Is the point when x is equal to 0, our gradient, they're telling you which this is basically if I give you something like this, I say g prime of 0 is equal to 0. I'm telling you which this is the turning point. This is the x value of the turning point. That's what they are giving you. After giving you the x value of the turning point, well, now you need to find the y value of the turning point. All right, and then wow, you are not looking for A, B, C, and D. You don't want them. You can draw this graph without looking for those things then. Come and do this then. Nine. And we are one question there, which you know how many marks?